IGCSE Computer Science Syllabus Statement 2.1.1b. And I'm not going to read all this. But, yeah, these are the things that we're going to be covering. This video is pretty much top-down design, because we use these to represent, systems and subsystems. So, yeah, let's get started. So, top-down design is breaking down a system into smaller subsystems, and breaking these subsystems down into smaller subsystems until each subsystem performs one task. So it's kind of like what I was saying, this video is more to do with, well, it's pretty much top-down design, but we're looking at ways to represent these subsystems and systems. But we'll get to that soon. So, top-down design is a method of breaking down a problem into smaller problems. And once we look at structure diagrams, you'll see what this means. So doing this allows several programmers to work on different subsystems. And what this does is makes the design process more efficient. So we had a look at one structure diagram in the last video. So structure diagrams are used to represent top-down design in a hierarchical form. So we looked at this. We looked at the computer science course in a structure diagram, but it's pretty obvious that this isn't really like anything to do with programming. This is just grouping a course into, like, breaking down a course into topics and subtopics. But it's just so that you can get the idea. So let's look at a real structure diagram. So we have a message encryption system. So this is a program which encrypts and decrypts a message. So this is how it works. We break it out. We break it down into two parts. We have the encrypt part and the decrypt part. So the encrypt part can be broken down into input message, encrypt message, and output encrypted message. And the decrypt part could be input encrypted message, decrypt message, and output message. So when we say encrypt message and decrypt message, we could refer to a subroutine, which is on the list, so that's what we'll look at as well. But this could also be broken down into smaller chunks, but we won't look into that now. So a flowchart is used to represent the steps for a system or subsystem, and it's in the order that they are executed, the steps. They're used to communicate the algorithm, showing how a system or subsystem works. So they're usually used in the planning process when you're making a huge program. You could use a flowchart to represent systems or subsystems, just to make it a bit easier to understand what you're doing, and for other people to understand what you're doing as well. So this could be the encrypt message subsystem. So you input a message, encrypt it, and output the message. And that's it. But we'll look into flowcharts later in the course when we actually start building them. I'd say that it's not necessary to learn them from the past papers that I've seen, because as in learn how to make them. But it's still good to actually learn how to make them, just in case a question says design a flowchart which does this, because usually it says you can use pseudocode, programming statements, or a flowchart. But it's good to know just in case. So pseudocode is a notation resembling a simplified programming language. So it's kind of like looks like this. Like flowcharts, they're used to communicate the algorithm, showing how a system or subsystem works, but we have lines instead of boxes and arrows. So I'd say pseudocode is a bit better. That's just my opinion, but other people may find using flowcharts a bit easier because they can trace them. Pseudocode is a little bit, it's text, but I don't know, I just find pseudocode easier and a lot smaller, as you can see. There's this compared to what we had before, but what we had before, we had a start and end. Here, we don't. A library routine is a set of programming instructions for a specific task available to use. It's debugged and tested before being made available. So a library routine is pretty much something that someone makes, which other people can use in their own programs. And that could be, for example, I don't know, a program that square roots a number or something like that. A subroutine is a set of programming instructions for a given task that forms a subsystem. Subroutines are written in high-level programming languages and may be referred to as functions or procedures or methods. So that's pretty much a way to break down a huge program. Instead of having like your entire program in one sort of block, you could break it up into different, into smaller blocks. And the benefit of that is it makes it easier to actually read and makes it easier to use. And you can also run one block multiple times. So this statement falls into this video because it's similar to what we've learned. And this statement comes a bit later, but I decided to put it in here now because you might as well learn it now. It links. So standard methods of solution. Some tasks are needed frequently, so like taking the square root of a number. So these tasks are referred to as standard solutions. So when we say that it's needed frequently, we mean that we use it quite a lot. We may need to take the square root of a number quite a lot when we're looking at a lot like programs that we could program. And usually tasks like these are required quite a lot. So like a lot of applications, a lot of like programs that we could use these in. So what high-level programming languages can do is they can provide these standard solutions as standard functions or procedures or methods or whatever. So that's pretty much it for this video. And the next video I can't remember because I made it quite a while ago, but yeah, you'll find out. Oh yeah, I was going to say library routines can also provide standard solutions. So, people can make a standard solution and then give it to other people. It can be made available to others. That's it.